21 says secant of theta equals 6 over 5. So remember that secant is the reciprocal of cosine. So that means this is hypotenuse over adjacent. So you can draw your triangle, and if you make this theta, that means this would be 6 and this would be 5. And so then you just do Pythagorean theorem to find your other side, which would end up being 36 minus 25 is 11. Square root of 11, is that true?
Yeah.
And so on those questions, just like the one we did in our notes, figure out the two sides they're giving you, label it, do Pythagorean theorem to find the third side, and then you can find all your other trig functions. No calculator needed, no decimal needed, just drawing your triangle.
I multiplied 5 out of the fraction, and then I took secant, and I was like, oh wait, you can do secant, so then I was like 6 over 1 over cosine.
Oh, Angel, let's not say what you did.
6 times cosine.
Other questions?
I mean, we could do 22 to 24.
I'm going to make Nick do it. He has nothing else to do in Calc Lab. Math team. Look at 23. 23 says, a forester 200 feet from the base of a redwood tree observes that the angle between the ground and the top of the tree is 60 degrees. Estimate the height of the tree. So here's my tree. Um, 200 feet away is this guy, and he observes that the angle between the ground and the top of the tree is 60 degrees. So anytime there's a story problem, draw the picture. It should be a triangle. Find the height of the tree, which means we're looking for this side of the tree. And so again, think about what side you know. You know the opposite side of 60, you know the adjacent side of 60. So to me, it makes sense that for 23, we would set up the problem tangent of 60 degrees equals opposite, which is h over 60. Nope, just kidding. Over 200.
I always don't know, like, where the limit of degrees.
What do you mean? Like where? But it says the angle between the ground and the top of the tree. So between the ground, like he's 200 feet away. Here's the guy. And he notices that the angle between the ground, so we have to come from here, also known as the angle of elevation. A forester. I think that's about 60 degrees. One time there was a tree at my old house, and it always seemed like if it fell over, it was going to hit my house, like it was going to be pretty close. So I told my husband that we should measure how far away our house was from the tree, and then measure the angle so we could approximate the height of the tree to figure out if it would hit our house or not. And he said, let's just take our chances and see what happens if it falls. Luckily, it never fell. We talked about those special angles, 30, 60, and 45, 45. Which means you could give me like an exact answer, but I'm also okay with you using your calculators in degree mode. You could just multiply by 200 times the tangent of 60 degrees. Oh, I'm in radians. 346.4 feet would be the approximation there of how tall that tree is. Definitely you're going to have to set up problems like that on tests, on a quiz. We're looking at having a quiz on Thursday of this week if all goes as planned. We'll see how far we get. I'd like to, it's a short quiz, I'd like to just review, go over homework that day, review, and then take the quiz like the last 20 minutes of class. Instead of doing a whole day review and quizzing the next day, just so that we can kind of try to stay on track. But we'll see how far we get. That definitely could get pushed back a day if need be as we go through here. But that will be our first quiz of the semester. Okay? Okay? Good? Sorry, I thought I said something. Homework? I mean, notes? I'm making you do work every day, Aaron. Here are day one notes. They're not written on, but it was really just go show us All right, let's see how far we get. Again, really stinks that the people that haven't taken pre-cal are not here on our delay days, because I really wanted to talk about using a calculator, and so tomorrow we'll see what questions they have over this. But really important when we're doing trig that you know how to change between degrees and radians on your calculator, and that you know how to enter stuff in on your calculator. So probably you've noticed that your calculators have sine, cosine, and tangent buttons. So if they ask you to find the sine, cosine, or tangent, you can just type that in your calculator and get that approximation. And so I think on Friday maybe we talked about degrees and radians a little bit, but if not, you want to make sure you look on your calculator and you find that button. And so if I'm going to type in the sine of 47 degrees in degree mode, I'm just going to type that in my calculator. And so you just want to check that you get the same answer that I do. And I got 0.7314. If we're rounding to 4 decimals, you have to round that one up. So if you don't get that on your calculator, you want to let me know so we can make sure that we're doing this correctly. Anyone need calculator help? Anyone need a calculator? I throw calculators in pre-cal all the time, and call Barry's my new TA in second hour, and so the first day he was TA, Eric Drawball, nope, Dylan Drawball was like, Eric's his brother, I'm really not making that up. Dylan was like, I need a calculator, and he sits in the back row, so I chuck one at him, and Colin was like, freaking out, because he did think I should those things. Something else to remember how to do is how to do the reciprocal functions on the calculator. Secant, cosecant, and cotangent are not on the calculator, but remember they're reciprocal functions. So if you see the secant of 1.3, remember reciprocal means flip it over, like 1 over. The reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. The reciprocal of secant is cosine, so that would be 1 over the cosine of 1.3. So that's how you enter on your calculator. You only have sine, cosine, and tangent on your calculator. So if they give you secant, cosecant, or cotangent, you have to type it in like this. Also notice there is no degree symbol after 1.3, so you have to change it to radian mode. And in radian mode, you would hit 1 divided by cosine of 1.3, and you should get like 3.7383. Did you get that? We'll use our calculators a lot during this chapter. When we have a test over this chapter, there will be a calculator and a no calculator portion of the test. The calculator portion, I can't help you during the test. If you say, how do I type secant on my calculator? I can't answer that. That's something that's going to be testing you if you know how to do that. So make sure you ask those questions before the test. Questions about those two? I put on here these same degrees and radians that we wrote out before, so I don't know that we really need to write them out again. But remember that you can break up a circle in 8 equal parts or 12 equal parts, and you can count by radians pretty easily. So like on this one, if you broke this up into 8 equal parts, remember just like we did on Friday, I believe, if this whole circle, if the whole way around the circle is 2 pi, and I break it up into 8 equal parts, each section is pi fourths. And so that's why when we talk about 45, 45, 90-degree triangles, it's why it's so important, because we can count by fourths around our circle, which is the same as counting by 45 degrees. And so just very quickly to throw this up here again, 0 pi fourths, this would be 2 pi fourths, which reduces to pi halves, 3 pi fourths, and 4 pi fourths adds up to 1 pi. One more than that would be 5 pi fourths. One more fourth than that would be 6 pi fourths, which reduces to 3 pi halves, and 7 pi fourths is 1/4 away. So very quickly, as we continue to talk about these special angles, these pi fourths are going to be angles that we want to be aware of. The other ones are the 30, 60, 90 triangle. Increments of 30 degrees, right, are going to be on your circle in radians. you have 2 pi, and you break this up into 12 equal parts, that's where these are increments of pi 6. And so 12 equal parts, that means like 1, 3 from each section, right? 4, 5, 6, 7, 8, 9, 10, 11, 12. So not even the right. And again, for some people, they do better with keeping 6 and thirds, but you can always just count by 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. I was off a little bit. But some people know this. Like this one is pi 6. That's 1/6. Right? Up here is pi halves. Here's 0. Over here is pi. So some people, like I always remember the 6 are always one little notch away from the axis, right? This is 1/6 away from pi, so this is 5 pi 6. This is 1/6 more than, so that's 7 pi 6, because that's 1/6 more. And this one over here is 1/6 away from 2 pi, which is 12 pi 6. That makes that 11 pi 6. And then the other ones, if you just count, this is 2 pi 6, which reduces to pi thirds. All the other ones that are left are thirds, right? This is 1/3 pi. This is 2/3 pi. 1 pi is 3 pi thirds, so this would be 4 pi thirds. And over here would be 5 pi thirds. I guess I forgot my 3 pi halves. Again, a couple of different ways you can think of it. But again, this is why I've been stressing the 45-45-90 triangle and the 30-60-90 triangle, because these are our special angles that we want to know. And again, those of you that have been in pre-cal know the unit circle, and you know that these are the angles in the unit circle, which is why we stress about them so much. Okay? There you go. Okay, so let's talk about any angle on that circle that I just drew. When we talk about SOHCAHTOA, we're talking about only acute angles. That means we're only talking about angles in quadrant 1, angles less than 90 degrees, because in a right triangle, only the angles less than 90 degrees fit in that category. But if we want to talk about trig for any angle, we want to talk about it in terms of x, y, and r. So think about, let's just draw in a point here somewhere. How about, actually let's draw an angle. Let's just draw in an angle out here in quadrant 2. Maybe that's what I want to do. Yeah. And let's find a point on that terminal ray out here. And let's just call that point x and y. No matter where you are in the coordinate plane or on a circle that you could draw in here, that point, whether it's in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, that point could represent the sides of a triangle. And so what we want to talk about are this triangle that we could draw in. I can't really draw in the right triangle over here, right, the angle that I'm measuring, but I could drop down a side here, and I could make a triangle. Think about what the sides of that triangle would be. This would be whatever x is. Do you agree? Whatever the x value is of that point. And the height here would be whatever the y value is. And the hypotenuse, we're going to say, is r. And notice what they tell us up here. Let theta be an angle in standard position with x, y, a point on the terminal ray, and that r equals the square root of x squared plus y squared. And r can't equal 0, they say. What is this a version of? What? What'd you say?
I was there.
What'd you say? Pythagorean theorem, right? Pythagorean theorem says a squared plus b squared equals c squared. They've just replaced a and b with x squared and y squared. they just took the square root of both sides. So this is just Pythagorean theorem. If you want to just think of a squared plus b squared equals c squared and not r equals the square root of x squared plus y squared, you can. But it's just Pythagorean theorem. Don't stress too much about that. R kind of stands for the radius, because think about if we drew a circle, this is going to be a terrible circle, but if we drew a circle through that point, oh, that's awful. That would be the radius of the circle. That's what the R stands for. Pretend that's a nice circle, but it's not. We don't ever draw the circle in, but that's where it comes from. I'm going to undo my circle because it's so bad. So instead of doing SOHCAHTOA, we want to think about these ratios in terms of x's and y's. But it's the same idea. If this is my theta now, you can still think of SOHCAHTOA, but you got to think in terms of x's and y's now. So opposite over hypotenuse. Sine is now y over r. Cosine is adjacent over hypotenuse, which is x over r. And tangent is opposite over adjacent, which is y over x. We do want to say where x does not equal 0, because if x equaled 0, then our tangent would be undefined. Notice I didn't include that on sine and cosine because r cannot equal 0, which means sine and cosine are never undefined. And for cosecant, secant, and cotangent, we're just going to flip them over, but each one of those is going to have a restriction because x and y cannot equal 0 or they're undefined. So cosecant would be r over y, where y cannot equal 0. Secant would be r over x, where x cannot equal 0. And cotangent would be x over y, where y cannot equal 0. And so you might say, why do I teach SOHCAHTOA if the next day you're just going to tell me that I need to do this? Well, SOHCAHTOA is always something to go back to, but SOHCAHTOA only applies to angles that are less than 90 degrees. This applies to any angle, anywhere, graphed on a coordinate plane. And so that's why this is a better thing to learn.
That is the cool thing, like, all this is like the same.
All exactly. Most of this are exact notes from Freakout that I've copied and pasted and reordered.
So what is the radius of the unit circle 1?
It just works out really nice that the radius of the unit circle is 1, that we make it 1. You really could pick anything, right? Like if you pick, the ratios would be the same. If the radius was 4, the ratios would be the same. You'd have to just do a lot more simplifying. Does that make any sense? Yeah, I'll have to, I'll look up why do we use unit circle 1. I think just because it works out so nicely, right? To pick a unit circle 1, but I don't know. Yeah, like why don't we pick a 4 unit circle and have a radius of 4? I don't know. I don't know the answer to that. Alright, so here's the idea of now instead of saying, here's a triangle, find the values of theta, now I can give you a point, and you should be able to give me the values of it. I'm going to draw a picture on this one just so you can see it, but just know you don't really have to draw a picture if you know the ratios, because this is x, this is y, and could you find r if you know what x and y are? Yeah, and that's the idea of you don't necessarily have to draw a picture because you know that r equals the square root of x squared plus y squared. R equals the square root of 144 plus 25. That's going to be 169, and the square root of 169 is 13. So, if you didn't want to draw a picture, if you know x, if you know y, if you know r, you just use those new ratios. I'm going to draw the picture. I'm not actually going to label I'm not going to make 12 marks on this, but I'm just going to mark this off as -12, and I'm going to mark up here off as 5, and I'm just going to kind of connect where those would meet, just to show you that this would be the angle. And if the picture helps, draw in that triangle, and you can label, this is 13, this would be a height of 5, this would be negative 12, and your theta is always the angle that's coming from the origin, the acute angle, which would be this right here. So if the picture helps you, by all means draw the picture. But the idea is you don't necessarily need a picture, because you're going to memorize sine is y over r. Even if I didn't have this picture, I know y is 5, I know r is 13, so I can say that sine is 5 over 13. Which is the same thing that I would get here, opposite over hypotenuse. Cosine is x over r. X is negative 12 over 13. Notice we get a negative value. In quadrant 1, you never get negative values. SOHCAHTOA, you never get negative values when you're doing those, because it's always in quadrant 1. But now that we're outside quadrant 1, that's where we can get a negative value, because x is negative. And tangent is y over x, which would be 5 over negative 12, and it doesn't matter whether you put the negative with the top and the bottom, negative 5/12 is the same as 5 over negative 12. Do you see how you can do that without having to need a picture every time? That's another reason we don't want to depend on SOHCAHTOA all the time, because we don't always have a picture. We always want to draw a picture. What time did we get out of here? 24? Maybe we can do it. We can push through. Let me go back. No? So, signs of trig functions. Because all the trig functions are in terms of x or y or r, we can figure out whether sine, cosine, tangent, and their reciprocals would be positive or negative just based on what quadrant we're in. So, first of all, remember that these are our quadrants, 1, 2, 3, 4. Also remember that we label quadrants with Roman numerals, like that's a proper notation, goes in counterclockwise. And think about the signs of x and y. Every point in quadrant 1, the x is positive and the y is positive, right? That's why in quadrant 1, all the trig functions are positive. So I'm only going to write sine, cosine, and tangent for each one of these. But know that if sine is positive, then cosecant is positive. If tangent is positive, cotangent is positive. Like they go together because they just flip over. I don't think you ever need to memorize this chart that I'm putting on here. I just want you to think about it. And when you're solving a problem or doing something that you need to know which quadrants are positive or negative, you should just be able to think through this and be able to do it very quickly. Because if sine is y over r, if this is x over r, and if this is y over x, in quadrant 1, a positive and a positive can only equal positive, which is why quadrant 1, everything's positive. But no other quadrant are they all the same sign, because things matter, things change. In quadrant 2, do you agree that x is always negative and y is always positive? Not y. Is that true? So think about, sine is y over r, cosine is x over r, tangent is y over x. If sine is y over r and y is always positive, r is always positive, sine is still going to be positive here. But cosine is x over r, and a negative over a positive is a negative. And tangent also has an x in it. A positive over a negative is a negative. Yes. Never. Because it's a square root, right? The radius will never be negative. In quadrant 3, both x and y are negative. So that means sine and cosine are going to be negative. Again, why do I know that? Because of this right here. R is never going to be negative, but y and x are, so that makes a negative number. But really cool, what happens with tangent? If we have a negative y over a negative x, that becomes positive. Here's what else is really cool. Each trig function is positive in 2 quadrants and negative in 2 quadrants. What happens here? Positive x, negative y. So now y is negative, so sine is negative, cosine is positive, and tangent is back to negative. Again, you're never going to have to like reproduce this chart. It's just supposed to help you. The bell's going to ring in a second. But let's look at least one of these questions on here. If I gave you a problem like this and I told you which, is it going to be positive or negative without using a calculator, just based on where it is. For 299 degrees, what quadrant would 299 degrees be in? Yeah, this is 270 degrees, so 299 would be down here in quadrant 4. So think about cosine. Cosine is x over r. In quadrant 4, do you agree cosine has to be positive? So I can just say positive. They don't actually want the value of it. They just want you to think about the quadrants. They could also be in radians. 2 pi thirds, we just drew that out, but 2 pi thirds is over here. In quadrant 2, is tangent positive or negative? Negative. All right, so I'm kind of just building on to what we did on Friday, but really, really big, important things that we're doing. Is that all? That's all the notes, right? So notice there's not a ton of problems, but really important problems that you're looking at. And so make sure you try these and come in tomorrow with questions. I don't foresee us having a 2-hour delay tomorrow, but I didn't really foresee us having a 2-hour delay today, so who knows? I don't live on, no, hold on, okay. No bus service,
Wow.
icy road, no bus service.
Yeah, and then, oh my gosh, all these people move.
People move a lot, it's crazy.